Hello, in this video we are going to solve another example where we are going to use the implementation of economic order quantity model. So let's just get to it. So we do have a department store here located in Chicago. They sell 1,700 coffee makers per year. The purchase price of each coffee maker is given to us as $70. Okay, and the ordering cost for this product is also given as $90. Okay, and then the holding cost. This is a strange language that the question is going to be using. The holding cost is given as the 30% of the unit purchase price. So if this is given as the 30% of our purchase price, it will be $21 per year, right? And then the question says, compute the economic order quantity and the total annual cost of ordering and the holding inventory of coffee makers. All right, so are we given the demand? Yeah, we are also given the annual demand, and that is right over here, 1,700. Okay, so these are the summarized information here. Remember our EOQ formulation. Of course, you don't have to memorize them. Memorize these formulas. You will be provided to use them whenever you want. Just make sure that you can implement this equation. 2 times D times S divided by annual hauling cost, and 2 times 1,700 times my S is $90 divided by $21. Remember, in the previous question, our holding cost was given to us directly. In this case, the holding cost was given us as the 30% of the purchase price. And questions might be structured in this way. And if you do the math, you would get 120.7. And of course, you cannot really order fractional number of coffee makers. So I will round this up to 121. It's okay to deviate from EOQ just a little bit. Like you can round this down or round this up, but you will see that at the optimal solution, while you're calculating the total cost, your ordering cost is not, if you deviate from your EOQ, your ordering cost is not going to be equal to your holding cost. And I will show that in a moment later. Okay, so now since we know of our EOQ, we can calculate number of orders per year, and that is 1,700 divided by 121. And if you do the math, it should be 140.5. Well, of course, you can round this up or down, but I will round this up. Time between orders will be, again, EOQ, 121 divided by 1,700. And if you do the math, this will be 0.071 years. Okay. Now, in 1 year, we do have 365 days times 0.071, and you would get 26 days. So in your optimal strategy, if you have a system ready, you will initiate this order of 121 coffee makers in every 26 days. That is going to be your inventory strategy. So let's calculate holding costs and ordering costs for this mechanism. Remember, our EOQ was 120.5, but we rounded up. You will see the impact of it here. Our holding cost is $21, and our demand is 1,700 divided by 121. This is our number of orders, and then our ordering cost, our S is $90. So if you calculate them separately, you see that this is 1,270.5 right? Plus 120, 1264.45. As you can see, since we deviated just a little bit from our EOQ, these two costs turned out to be different, which is fine because we cannot really, initiate a fractional amount of coffee makers. It has to be integer. And then the total cost would be 34.95. All right. These are the ways that you can do these kind of calculations by hand. Let me just quickly switch to the Excel file. Again, you can see this Excel file in your notes on your course page. I already set this up for you. So for the first one, remember for the truffles problem, for the first problem, our annual demand was 12,000. Ordering cost was given us as $6 per order. Carrying cost, inventory holding cost was given us as $16, and the number of working days was given us as $320. These are all the formulations that you will ever need when you are trying to do this calculation. So if you encounter another problem just like this one, all you have to do is to change these parameters, and these numbers are going to be calculated for you. So as you are working on your assignments or your Excel, experiential learning activity problem, or your test, you can definitely use this Excel file. So this second one is basically the question for the question that we just solved. And here on top, you can see the parameters, and the solution is just implementing the formulas that I just showed you in Excel. So again, if you encounter any problem like this one in your assignments or in your tests, you are more than welcome to use Excel for solving it. But you have to be very careful when you are trying to round things down or up. Make sure that, as you can see, the EOQ here is in fractional amount. Make sure that you round this up or down, and then make sure that you know what kind of calculations are going to be changing based on that. Okay, thank you so much for watching. That should be the end of chapter 16.